Okay.
Yes, you can start now.
Hi everyone. I'm Parth. I recently graduated from University of Delhi, and with me here is Shubham, who is currently undergraduate at University of Delhi. And last summer we both worked on as intern in Linux Foundation networking. So our projects were uh, uh, mine was cloud software delivery validation, and Shubham was working on hardware delivery validation. So we will be presenting these two technologies today. So these are quite simple technologies. We are not reinventing the wheel. So but but they but they provide a important function, important value to building data centers. So if if we talk about data centers, then they are very large, complex, and they have lots of components, and they involve lots of building them involves lots of vendors, from hardware vendors, software vendors, uh, network function vendors, cloud software vendors, application vendors, and so on. Um, and it takes months to build a data center. So what hardware delivery validation tries to target is to validate all kinds of hardwares, which could be servers, network functions like switch, routers, etc., in that are used in building data center. As well, similarly, cloud software delivery validation aims to validate all the cloud components and services of cloud stack. So, so what so what values these provide is, as all kinds of industries are moving towards automation to reduce operation expenditure. Uh, these uh, these kinds of validation checks brings confidence to cloud provider, that what all their components are running and healthy. As well as if anything goes wrong, if there any component that starts failing, then these tools helps them to debug them faster to uh, sorry sorry for interruption. So yeah, so HDV and SDV, this work initiated in OPNAP and CNTT communities in January of this year. CNTT proposed that there is a need for a there's a need for a tool that does hardware validation of hardware, all kinds of hardware in a data center, and uh, and so they brought this up to CVC committee to include this in OPP infrastructure testing for certification program, and further OPNFB took the responsibility of making this tooling. So the goal of this hardware validation tool should uh, uh, was to so that was that it could run on large deployments and verify lots of hardware, their settings, their configuration, or cabling between them, and so on. And it should also accept a standard descriptor file of the whole cloud. Um, so okay. Yeah, so the descriptor file they so for descriptor file, the community started initiated the work for PDF2. So PDF2 is a human or as well as machine readable document. It's a JSON document which contains all the kinds of details that 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 uh, that are related to a data center. So this is same as a cloud design document which is used while building data center. And uh, and right now the new version of PDF 2.0 aims to capture all the requirements for HDV, STV, and fill previous gaps with PDF 1.0. Uh, and if we look at the new PDF, then it basically divides the whole PDF into three parts. One contains the generic information about the cloud. So these could be rack details, zone, and user details, then deployment type, what kind deployment details, what is Vim, what kind of Vim we have, as etc. Then we have server details. In server details, we have details of each and every server in the cloud. So there could be hundreds of thousands of servers in a data center. So what we use here is a class. So what we use here is we define generic roles contains a type, few details about deep details about hardware. So using these roles, we generate list of servers. So a data center can have various kinds of servers, for some dedicated for compute, some for network. So we reuse these roles to generate all those list of servers. Then we have network fabric details. So all this work is in very early stage, and it's under development. So and if anybody want to give any feedback on PDF or HDB or SDB, you can give after after the talks. So let's start with HDB. Uh, so, okay.
Hi, so I am Shubham, and as Parth already mentioned, I worked on this project in last summer during my internship with Elephant. So let me introduce to the project. So HDV, abbreviated as Hardware Validation Tool. So it is an open source multi-vendor tool to automate the verification of a bunch of DC hardwares together and generate a report from this verification, so the lab person or any user can analyze those report and point out the faults and fix them quickly. So the the best time to apply this HTTP verification should be just after connecting those hardwares to the power source and to the network. So it is completely software independent, means that it should be applied before the deployment of the cloud or any NFV cloud, and it also OS independent. So we can apply it just after connecting the servers to the network and power source before the deployment of operating systems. So the main aim of this tool is to reduce the validation time in verifying the larger deployments, as counterpart of it's by default. In default way, the person go to each and every hardware and check whether its wiring is connected, whether the number of storage devices is working fine, or the fans are working fine. So all these checks can be done in an automatic way to save the time of those manual process. So one, can you please change the slide? Yes. So one such deployment of HDV is CIR HDV. So it is hosted under OpenNF free. So this is a very rough diagram of the HDV tool. It takes input the, as part this describes the PDF 2.0 file, and another file is OPNF HDV specific test case file, which contains the number of test cases. Which okay, so it uses HDB file to get the list of the servers and the credentials to access them. Currently, it supports Redfish, so it gets the credentials of the Redfish interface for all the servers and the list of the servers, and run all the test cases on each of the server, and gives the web-based UI-based report to the user. So I will also explain how this test case file looks in the latest slide. Can you change the slide? So this is the very big picture how we are looking HTV. So let me start from the right side. As you can see, suppose this actual hardware is some kind of data centers or hardware labs, and this inspection tool is comes under the HTV. It uses some protocol, out of band management protocol. Currently, we are stick with Redfish to access those hardwares, and run all the test cases describes in the test case file, and generate a report of the current status of the hardware. Now, then this status of the hardware will be taken as an input by the this comparing tool. The comparing tool will test the hardware report with the PDF 2.0, which will be filled by the operators. So this means here we are checking the hardwares with the expectations of the operator. So it stands with the, if we check this report with the PDF 2.0, that means we are checking whether the hardware stands out on the expectations of operators or not. So the another file to check is the CNTT min requirements file. So this file is generated by the CNTT itself. It's kind of in a certification purpose. So if comparing tool checks the generated report with the CNTT requirement files and it says, okay, the file has been passed. So it can be used as some kind of certification where the hardware will have the certificate that it is okay, or it stands out on all the parameters that are required to deploy the NFT cloud over it. Further, this PDF 2.0 can be used to generate the different manifest files which will be used by the different installers like Airship to deploy the cloud over the hardwares. Next slide. So we are at the very early stage of the HTV, and one version first has been released. So at this time, this supports Redfish for the out-of-band management of the servers. Like we were also planning to use IPMI, but like because of lack of input from the community, or it was quite old, so we stick with the Redfish as it is a new alternative for the IPMI. Then we are using Redfish for the moment, and the current version includes 40 checks that was related to CPU, BIOS, networking, storage, and these checks are included, and there are many more also. So, and the report comes out from the tool is the GUI based, and also it gives the report in the YAML so that when someone can build a software in above it and take those files as input. So we also support YAML file. Also, we push the data to the test API. So test API, you can think of like a big storage pool for the OpenOffice to softwares where all the OpenOffice projects send their report to the test API. So it preserves them and they can be stored and examined, analyzed later anytime. So during my internship, I used the HP ILO4 server. So it is tested on this server, and we make sure that it can be easily extendable to other servers also. So also like it has a proper user and developer documentation at the moment. So this is the test case of the test case file looks like, which I have mentioned earlier, the test case file. This is how the single example of the test case. So test case is about to checking the CPU information. So most of the fields here are, by the way, self-explanatory. Still, I will explain all of them. So it's test case name, then this test case serial number, then we have to enable it, or the if we make it false, then the tool will escape it and will not check this case. Then basically Redfish is a HTTP based RESTful interface. So we have a URL. We our tool will you can look the last key, the URL. So tool will use this URL and get the response from the server, and the expected result response from those server, and the expected result here will be this expected result is the subset of the keys we will found on the response from the actual server. So suppose for checking the CPU here, we want the number of CPUs count should be 2. So we are on the server, the CPU should be 2. Their manufacturer should be Intel Corporation. So all these checks we can mention here. So we can also give an array. Suppose process architecture, we are okay if it is x86, ARM, or OEM. So we can put all in the array. And for the URL, to define URL, suppose we want to check all the CPUs of a particular system. So instead of giving us this curly braces here, we can put that system ID here, and the test case will check all the CPUs of that particular system. Suppose we want to give check for a particular system of a particular CPU of a particular system. Then instead of giving these variables, we can put those IDs here specifically, and also you can find more information how to create this tool in the user documentation too. You can move to the next. So this is how the report look like. This is an overview of the report. So uh, I tested well run this test on the server which was not aligned with the test case file, so that's why most of them failed. But generally, it is not the case. So this is an overview, and we can find a detailed analysis of the report in the next slide. Can you move to next? Yes. So this is how a detailed description of the test case look like. So here it gives the proper reason why the test case has been failed. In the description, you can see what is the test case which was applied. It was the test case with check model, and it is failed. Above in the red color, you can see the reason of the failure, the expected value, what was, and what was the return value. So it is failed due to some mismatch. And okay, next. Also, you can find the logs and all in the same particular test case files. So, as per the current HTV, there is a limitation that you can move to the next limitation one slide. Yes. So limitation we are facing is the sometimes the HTV or Redfish implementation sometimes varies between different hardwares. So which was a big challenge for us. So for coping up with this challenge, we decided to write a different test case file for every vendor. So still it is an hectic task to have a different test case file for every vendors. And the reason was sometimes you find some particular field in some URI of the Redfish, but it changes for the different vendor. You might find those keys in some different URL address. So as in future work, it will be great if we are able to find some generic way to write this test case file, and we might can use Odin for it. We are seeing like instead of directly talking as to make HTTP to directly talk to Redfish, we if we use Odin, and Odin give us a standard way to do it, and make we are able to make some generic test case file. Also, like as a expected result column, which I have shown you in 2 slides back in the test case example. If we move it from the test case file to the PDF 2.0, because it is kind of rewriting the test expected result in for the operator to write what kind of cloud he wants in PDF 2.0 and also in a test case file. So it would be great if we can take those fields from the PDF 2.0. So for this, we might need to work through HTML and as well as PDF also. So and the last feature that we can get is to do some uh, get feedback from the CMTTs to make some test cases like this one are the must pass test case, and this one are the optional pass test case for the cloud to be stand on the HTTP or certification and all. So thank you. That's it. Now HTTP parts ahead.
Yeah, so back to me. So now let me get you through the STV tool on the CIV project. So the implementation of STV tool. So if I were to define what this tool does is, then it's an open source automated installer manifest agnostic testing tool. So it performs quick status checks, health checks, or uh, of the cloud software deployment. And if it finds anything is failing, any component is failing, then it collects its details, its logs, and whatever else could be used later for debugging it. So this software validation is a post deployment tool. So once the cloud provider has his cloud stack deployed, then after that we will like to run this tool over the cloud and validate that uh, yeah, the deployment was successful. And while designing this tool, one of the goal was that it should support multiple installers. It could be extendable to multiple installers. And if you ask me that, well, doesn't this doing a functional how does this different is different from functional testing? So unlike functional testing, which does more in-depth testing of the cloud stack or whatever software component we have, SDV tries to just only make a status check or state check of the components, rather than checking the whole functionality of this, all endpoints and stuff. So currently it's in early stage. As I said, we are working with Airship 1.7 uh, deployment, but we plan to extend it to other installers and Airship too. And yeah, so if I were to give you the working view of how this whole stack is working, so you can think of the SDV tool as a single container, and it takes two types of input. So the first input it takes is the cloud, access to the cloud. So uh, we can have various kinds of cloud, so there could be various ways we could access them. In case of Airship, we need a kube config file, which gives us which gives us access to the whole cluster on which OpenStack is run. So Airship is an open OpenStack on Kubernetes deployment. So in this case, we need a kube config file, but in other deployments, we may need some other kinds of access. It completely depends on the type of installer. Then we have the PDF, which which has which has the actual description of all the software components of the cloud. So and so so the from the PDF we ask from the cloud owner, okay, provide us your PDF, and he will provide us, and we will our HDB tool will use all the details of the cloud from here. So PDF is like a source of truth for HDB, and then it what the SDB tool do is it looks at the PDF and sees that, okay, these are the requirement states of the cloud. So the cloud should be in these states. This is what the cloud owner desires, and then it goes to the actual cloud where it is deployed, and it tries to get what is the actual value which the cloud has. So how the cloud is being configured. This tries to map those twos, and if both desired and the actual value matches, then that particular check is successful. And if it's not, then we say that that particular check failed. So like this, we check various components in the cloud. So it could be our pod. We could check CPU allocation ratio. We can check our SRAOB or other network configuration. We can check monitoring components, whether they are configured properly or not, and like this we can check various other things, various other components of the cloud. Once the state validation tool completes its all its check, then it gives output. It gives the result as output in various format. So one of the format is obviously it's hosted in OPNFP, so it supports test API of OPNFP. uh, uh, Other than that, it supports its native resulting format, which has a validation report, which is like a summary of what checks passed and what checks failed. And and another and it has logs, files, and other artifacts whatever were used in the STB state tool. It also provides a results or JSON file. So this is this file contains all contains a very detailed description of in JSON format of all the cloud components. So all the checks, then what cloud component they checked, what was the desired state, and what was the actual state in the cloud. And like this, they have a JSON file which contains all the results. This can be further consumed by some other tool to do some kind of automation. So, and we can also, so the this SDV tool is quite extendable in all sense. So uh, uh, we can extend it to multiple, we can save results to multiple result API. So what we need. So if tomorrow we want to store in some kind of database, we can add here support for it. And similarly, Airship tool has plugin architecture for various installers. So right now we have implemented validator for Airship. So we can for tomorrow if we want to implement other installer, so we can give a completely different plugin for it and as a code, and we can the STV tool will uh, use it by looking at the fields in the PDF. Um, okay, that's it. So this is the report I was talking about. This is just a summary. So it contains all checks passed and checks failed, and the duration the test ran on. So this one in these checks are usually run in like 10 to 12 seconds. These are very quick checks and do not require lots of time. Yeah, this one has 150 seconds because I was running it over a VPN. It's a old result. I have it. Um, so this like this is a fraction of visualization because I couldn't capture all of it here. So I added a small part of it. So you can look, the visualization is a very long file. So it contains a detailed result of everything, all the logs it collects, all the detail it collects. So for example, let me go to um, let's talk about physical networks. So it goes to OpenStack and it gets details of physical networks from OpenStack, and then it matches these details with the PDF. What PDF wants the cloud to be physical networks to be configured, and if both the values matches, then the state remains okay, and if both values don't match, then it gives a fail, and in case of uh, if it's a software component, it can collect more details about it, it will collect its detail. So for here we have Elasticsearch. So in case of Elasticsearch, we collected more details over here and added to results. If our details are way too long, then or log file is way too long, we add it as a separate file and provide a link to it here. So so let me yeah that's it. So the the purpose of this talk was to get feedbacks from everyone, like what you think about it, uh, and what could be more features that it can include, and if and we can also discuss about PDF uh, and other things. Well, yeah.
So we have a couple of questions from Chengappa. Um, so first one is, doesn't the X testing framework defined by OPNFAC entity do something very similar?
Uh, no. The the existing tool tries gives a interface for automated testing. So what uh, we can for suppose this SDV tool is one of my testing tool. So what I can do is I can containerize it and provide two files as required by X testing, and I can add those files and build a X testing container. Now what I can do is for this my SDV tool, I have created my X testing container. For SDV tool, I can create for VSWorf and like other testing tool, I can create their uh, I can containerize them and add functionality for X testing. So I can provide this to my continuous integration system and it for automated testing. So X testing tool itself doesn't do any testing, but it tries to provide a unified way to integrate various testing tools, which can have completely different way they test their code. Um, So existing itself doesn't do testing. It provides a interface on which we can attach various testing tools.
Okay, and are there any overlap with the test cases between X testing and HDV test cases?
Existing do not has its own any test cases. Uh,
And what do you think? What would be the future of HDV with announcement of Aniket community? I think HDV is included in the new version, right?
yeah.
Yeah.
So this the SDV was proposed by CNTT, and CNTT is very much interested in this because it builds confidence that all the hardwares are configured. Because if hardware is not working fine, if anything is going wrong, then how can software running on it can work? And the sysadmin can just put their head on and waste all their time in thinking what's going on. So SDV easy makes that process easy. So
And what do you
yes,
think? Uh, okay, one more. I believe the current operating version of Airship is 1.8 and also 2.0 beta is in play. Have we used SDV, Software Delivery Edition, against these
uh,
versions?
so we are planning to extend it. So right now, we in lab we have Airship 1.7 running, and Airship 1.8 we are upgrading to Airship 1.8 also. So on pod 17, um, yeah, on pod 17 we are upgrading to Airship 1.8, and on pod 15 we are running Airship one-
1.7.
1.7. Also we are planning to include Airship 2 uh, s- uh, 2 in future, once we upgrade our lab to support Airship, sorry, to support Redfish interface. Once we have hardware available, then we will move to Airship 2. Yeah.
And can we use these for both CNTT RI1 and RI2? Yes, I think yes, right?
Uh, y- yeah, it can be extended to various installers. So it can be any kind of installer. It can be RI1 based or RI2 based.
Yeah. So any more question, Chengappa and others? Okay. So
Um,
Prakash here. Validation.
yeah,
One thing I would like to know is uh, the CNTT is now renamed, right, as some new entity?
Yeah. So CNTT and OPNAV are merging. So as of January, the new foundation, which is merger of CNTT and OPNAV, will start. It is named
Mhm.
as Anuket. So
Yeah.
official TSC, officially the Anuket is planning to start its meeting from January after these Christmas holidays.
So Airship, you think will be able to 2.0 will be able to adopt this?
Uh, yeah,
Both
the
the hardware
HDP.
and the software?
Yeah. So hardware and software validation are like very pluggable in themselves, so we can extend them to multiple vendor implementations. Uh,
So you are starting with Airship, right? Begin with?
yeah, so to begin our development to see how it's going. So it's like something new we are trying to do. So we started with Airship. We had Airship as the available installer, which was active project in OpenFP back then.
So you see this integrated into Metal Cube or Ionic or both or with Cluster API? How do you see the relationship going with Airship down to this level?
Um, so
Both the software and hardware, are they part of the uh, metadata? Sorry, the manifest?
no, they consume the PDF. Now PDF itself can be built from the manifest.
Oh, I see.
So
Okay.
so manifest
That,
for Airship has this. So the issue was, sorry, the issue was every installer has their own version of manifest, and these manifests are like very huge. They can be bunch of documents. If you can look at the Airship pressure map itself, it's like very huge. So the what OPNAV decided that there should be a standard descriptor file, which which can replace these various kinds of installer manifest that every installer has. So all these installers can use a common PDF file for common format, PDF format, once doing their deployment. So our SDV and SDV tool are using this PDF itself as a source of truth for performing their validation.
Okay, that helps. Thank you.
Yeah, and the PDF enables lots of innovation in the industry. So for example, we can use PDF as input and to some tool, and we can generate a installer specific manifest. So suppose we have a uh, cloud details of a data center in format of in a PDF file. Now I want to deploy suppose Airship on my data center. So I can take this PDF file and generate a Airship manifest from it using some tool, and can provide that manifest then further to Airship. Uh, like this, there can be various things that
Thanks. I think got the essence of it. We can move on. Anybody else? Any questions? So can we end the record and pass on the baton to next?
okay. Uh, Thank you, everyone. Uh,
Thanks a lot, both of you, Partha and Shubham, both excellent job. And we'll like to hear the feedback once we come back next year on how things happen. Further. With that, we hand over to Vipin, I believe. Is that right?
Yes,
Vipin,
Prakash.
Vipin,
Vipin.